Good morning everyone. I welcome you all for this session. In this session, I am going to start the problems on friction. So let us start the first problem. So in this, a block of 150 Newton is at rest on a horizontal floor. So there is a block and the weight of the block is 150 Newton and this block is resting on a horizontal floor. If horizontal force of 108 Newton is applied on the block as shown in the figure, find the limiting friction and the coefficient of friction. So that means in this particular problem I need to calculate what is limiting friction, that means maximum friction, and then I need to calculate what is coefficient of friction, that is mu. So in order to calculate these two unknowns, I need to write the free body diagram first. Right? So first let us write the free body diagram for the block. So this is the block and the weight of the block is 150 Newton and always the self weight will be acting downwards and it will be vertical. So this will be 150 Newton. And a force is applied and the magnitude of that force is capital P is equal to 108 Newton. And this block is resting on the floor, that means floor is going to offer a reaction and that is called as the normal reaction, which will be in the vertical direction. So in the free body diagram I need to represent the normal reaction which is offered by the floor on the block. Let me denote it as capital N. If I apply a force in this direction, the body tends to move in the direction of the applied force. Therefore, the friction will be opposite to the impending motion and always the friction will be in between the two surfaces. Right? So the friction here, it will be opposite to the impending motion and let it call it as capital F. Here I need to calculate what is the limiting friction or maximum friction. So this is how you need to write the free body diagram in which self weight, applied load and the reaction will be there. Right? Now in order to calculate the unknowns, now I need to apply the equilibrium condition for this free body diagram. So I need to apply two equilibrium conditions. One is summation of Fx is equal to 0 and the another one is summation of Fy is equal to 0. So let me apply the equilibrium condition. Apply equilibrium conditions in which I need to apply two conditions. One is summation of Fx is equal to 0 and another one is summation of Fy is equal to 0. So let us apply the first one, that is summation of Fx is equal to 0. So in this free body diagram there are two horizontal forces. So this will be plus 108 and this will be minus. Right? So that is plus 108 minus F maximum is equal to 0. Therefore, F maximum is equal to 108 Newton. So I got to know what is the maximum friction and the maximum friction is 108 Newton. So let us apply the next condition, that is summation of Fy is equal to 0. So in this free body diagram there are two vertical forces. So this will be minus and this will be plus. So that is minus 150 plus N is equal to 0. Therefore N is equal to 150 Newton. Right? Now in order to find out the mu value, that is coefficient of friction, I am going to use one more equation, that is F is equal to mu times of N. Where F is, in this particular problem where F is F maximum, that is the friction. So this is coefficient of friction mu and this is the normal reaction. So in this equation, I know what is F value, I know N value, so easily I can get the value of mu, right? So mu will be equal to F maximum divided by N. Mu is equal to F maximum is 108 and this is 150, right? So this is 108 divided by 150. If you simplify this, the mu value will be equal to 0.72, 0.72, and there is no unit for mu, right? So this is how you need to solve the problem. So let us move to the next one, right? So let us move to the second problem. So in this problem, a wooden block rests on a horizontal plane. Determine the force required, case number 1, to pull the block, case number 2, to push the block, right? Assume the weight of the block is 49 Newton and the coefficient of friction is 0.4. So in this particular problem, there are two cases. I need to calculate what force is required to pull this block of weight 49 Newton which is resting on the horizontal plane. In the second case, I need to calculate what force is required to push the same block which is resting on the horizontal floor, right? So in order to solve this, I need to write the free body diagram for both the cases separately, right? So for case 1, first let us write the free body diagram. So this is the block and the weight of the block is 49 Newton. The weight of the block is 49 Newton. And in case number 1, the block is pulled by applying a force of P1 which is inclined at an angle of 15 degrees. So in order to apply the equilibrium condition, I need to resolve the inclined forces. So this will be the horizontal component, that is P1 cos 15. This will be the vertical component, that is P1 sin 15. Right? Next, this horizontal floor is going to offer a normal reaction on the block. So let me write that normal reaction, and the normal reaction will be always vertical, and let me denote it as capital N. So if you pull the block, the block is going to move in the direction of the applied force. Therefore, the friction will be opposite to the impending motion, and this is how the friction look in case number 1. Right? So this will be F is equal to mu times of N, where F is equal to mu is given in the question, and that will be 0.4 times of N. So this will complete the free body diagram for case 1. So in the same way, let us write the free body diagram for case 2. So this is the block. This is the block, and this is the self weight, and that is 49 Newton. And in the second case, the block is pulled by applying a force of P2, and it is inclined at an angle of 15 degrees. So I need to resolve this inclined force. So this will be the horizontal component, this will be the vertical component. This is P2 cos 15 and this is P2 sin 15. And in the same way, this floor is going to offer a normal reaction, and it will be vertically upward and always perpendicular to the surface. And this is N. So if you push the block, the block is going to move in this direction. Therefore, the friction will be opposite to the impending motion. So in case number 2, the frictional direction is towards right. So that is F is equal to mu times of N, F is equal to 0.4 times of N. So this is how you need to draw the free body diagram for the two cases. Now I need to apply the equilibrium condition for each case. I need to apply the equilibrium condition separately now, right? So apply equilibrium condition. Apply equilibrium condition for this. Summation of fx is equal to 0 and summation of fy is equal to 0. Let me apply summation of fy is equal to 0 first. So in which there are 1, 2 and 3 vertical forces. So here it is minus 49, this is plus n, and this will be plus P1 sine 15 is equal to 0. I am going to rearrange this equation where n is equal to 49 minus P1 sine 15, call it as equation number 1. Now let me apply the second one, that is summation of fx is equal to 0. So in this there are two horizontal forces. So this will be plus and this will be minus. So that is plus P1 cos 15 and this is minus 0.4 times of n is equal to 0. Let me rearrange this equation in such a way that I can get n. n is equal to minus P1 cos 15. Sorry, this will be plus. So n is equal to P1 cos 15 divided by 0.4. I am going to substitute this n here in equation 1. So put in equation 1, therefore P1 cos 15 divided by 0.4 is equal to 49 minus P1 sine 15. So in this equation there is only one unknown, that is P1. If you simplify this equation for P1, so the P1 is equal to 18.32. 18.32 Newton is the value of P1. So in the same way I need to apply the equilibrium condition for this free body diagram, that is summation of fx is equal to 0 and summation of fy is equal to 0. First let me apply the first one, that is summation of fy is equal to 0. So this is vertical and it is minus 49. This will be plus n and this will be minus P2 sine 15 is equal to 0. Let me rearrange this equation where n is equal to 49 plus P2 sine 15, call it as equation number 2. Now let us apply the next condition, that is summation of fx is equal to 0. So this will be minus, that is minus P2 cos 15 and this will be plus 0.4 times of n is equal to 0. So let me rearrange this equation. That is n is equal to P2 cos 15 divided by 0.4. So put in equation 2. Therefore P2 cos 15 divided by 0.4 is equal to 49 plus P2 sine 15. So if I simplify this equation, so that is P2 is equal to 22.79. P2 is equal to 22.79 Newton is the answer. Right? See, you can observe here, if you want to pull the block, you required 18.32. If you want to push the same block, you want 22.79. So that means in order to push the block, you required more force. In order to pull the block, you required less force. Right? So let us move to the next problem. Let us move to the next problem, and that is the third one. So in this problem there are two blocks. So here a block of weight 1000 Newton rests over block B which weighs 2000 Newton as shown in the figure. Block A is tied to a wall with a horizontal string, and what should be the value of P to move the block B, right? So in this problem, there are two blocks, and block A is resting on block B and block B is resting on the horizontal surface, right? Capital P force is applied on block B and block A is tied to the wall by using a horizontal string. So when you apply a force on this block B tends to move in the direction of the applied force. That means block B is going to move towards right, but block A is tied to the wall, therefore block A tends to move in the left direction, right? When you apply a force on this block B, this block is going to move in the direction of the applied force, that is towards right, and this block A, because it is tied to the wall, the block A tends to move towards left. So depending upon this impending motion, I need to decide the direction of the friction, and always the direction of the friction will be opposite to the impending motion. And one more point here, it is the coefficient of friction between these two separate is 1/4, and the coefficient of friction between block B and the horizontal floor is 1/3. So now there are two blocks. So now I need to draw two free body diagram. So one free body diagram for block A and another free body diagram for the block B, right? So let me draw the free body diagram for block A. Free body diagram for block A. Let me draw the free body diagram for block A. So this is block A. The self weight of the block A is 1000 Newton and it will be acting vertically downwards. And there will be a normal reaction which will be offered by block B on block A, and let me call it as N1. N1 is the normal reaction which is offered by block B on block A, and so this is the horizontal string, and in the string there will be always tension. Let me denote it as T, right? So this will be the tension, and this is how I need to represent the tension, and this will be T. So as I explained earlier, when you apply a force on block B, the block B is going to move towards right, but block A will move towards left. Therefore, the friction will be opposite to the impending motion, and the friction will be acting like this. This will be F1 is equal to mu1 into N1. So this completes the free body diagram for block A, right? Similarly, let me write the free body diagram for block B. So this will be block B. So this is the self weight, and the self weight will be equal to 2000 Newton. 2000 Newton is the self weight. So on this block B, there will be two normal reactions. One normal reaction will be from block A. One more normal reaction will be from the horizontal floor. So both the normal reaction will be perpendicular to their surfaces, right? So this will be the normal reaction, that is N1, and this will be the normal reaction, that is N2, which is offered by the horizontal floor, right? So when you apply a force in this direction, the block B is going to move in the direction of the applied force. That means the friction will be opposite to the impending motion. So here there will be two frictions because there is a contact point between block A and block B. At this particular surface there will be one friction, and at this particular surface there will be one friction, and both the friction will be opposite to the impending motion. So therefore this is the value of F1, that is the friction between the block A and block B, and this will be the value of another friction, and that is F2, that is the friction between block B and the horizontal floor, right? And they have applied a horizontal force, and that force will be capital P. So this is how you need to draw the free body diagram for the two blocks separately. So now I need to apply the equilibrium condition for each block separately. So I need to apply the equilibrium condition for the block which will be having minimum number of unknowns. So if I compare these two free body diagrams, block A is having minimum number of unknowns. So first I need to apply the equilibrium conditions for the free body diagram of block A, right? So let me apply equilibrium condition. So first for this one, summation of fx is equal to 0 and summation of fy is equal to 0, right? So let me apply the first condition, that is summation of fy is equal to 0. There are two vertical forces here, this will be minus and this will be plus, that is minus 1000 plus n1 is equal to 0, therefore n1 is equal to 1000 Newton. So along with these two equations, I have one more equation, that is F is equal to mu times of n. By using that equation or that condition, easily I can get one more unknown. So let me write this as F1, mu1 and n1. So here the mu1 will be equal to 1 over 4, that is the coefficient of friction between these two blocks, right? So let me write it as mu1 is equal to 1 over 4, and I know the value of n1 is equal to 1000 Newton. So that is F1 is equal to 1 over 4 into 1000. So F1 value will be equal to, if you simplify this, F1 value will be equal to 250 Newton. F1 will be equal to 250 Newton. Now let us apply the next condition, that is summation of fx is equal to 0, in which there are two forces. So one will be minus t, another one will be plus F1 is equal to 0. So therefore T will be equal to, F1 value is 250, therefore T will be equal to 250 Newton, right? So this is how you need to apply the equilibrium condition to get these unknowns. So by solving this, I got to know what is n1 value, and n1 value is 1000 Newton. Substitute here, n1 will be equal to 1000 Newton. Along with that, I know the value of F1 will be equal to 250 Newton. So substitute here, F1 will be equal to 250 Newton. So in this free body diagram, the unknowns will be P, N2 and F2. So by applying the equilibrium condition, that is two conditions, that is summation of fx is equal to 0, summation of fy is equal to 0, and one more equation, that is f is equal to mu times of n. So by using these three conditions, you can get the three unknowns easily, right? Now I need to apply the conditions for this free body diagram, where summation of fx is equal to 0 and summation of fy is equal to 0. Let me apply the condition summation of fy is equal to 0. So here there are three vertical forces, minus 1000, minus 2000 plus n2 is equal to 0. Therefore n2 will be equal to 2000 plus 1000 will be equal to 3000 Newton. Let us use the next equation, that is F2 is equal to mu2 into N2. So here mu2 will be the coefficient of friction between the block B and the horizontal floor. So this will be mu2, and that will be equal to 1/3, and N2 will be equal to, that is 3000. If you simplify this, F2 value will be equal to 1000 Newton. Now let me apply the second one, that is summation of Fx is equal to 0. So 1 will be, here it will be equal to, that is plus P. This is minus F1, and F1 is equal to 250, that is minus 250. So this will be minus F2, and that is minus F2. F2 value here it will be equal to 1000. Let me substitute as 1000 is equal to 0. So now the P value will be equal to, 1000 plus 250, that is 1250 Newton is the value of P. So let us move to the next one. So in this particular problem there is only one change, and this problem is very similar to the last one, but there is only one change, is the applied force. Here it is inclined, and the angle of inclination is 30 degrees with respect to horizontal. So you need to do this problem in the home, right? So this will be a homework. So the P value will be equal to 1210.43 Newton. This is the answer for this particular problem. So you need to draw the two free body diagrams separately. The only thing is, when you are going to solve this, particular free body diagram, here you need to resolve this inclined forces into vertical and horizontal. Then you need to use the same thing here. Then you need to apply the same condition to get the value. That is the only change, right? So let me end the session now. Thank you.